All right, welcome to this other lesson on what is the triangle inequality theorem. So we are going to basically the objectives. Okay, I can determine the relationship between the sides of any given triangle. I can determine the possible values of the third side given the values of two sides of a triangle. Now, what is the triangle inequality theorem? Well, we're gonna figure it out after we do this little activity on the mini lesson. Now, this is what I want you to do. I don't want you to start from the first problem. I want you to start from the second problem, and I'm gonna guide you through the process. Okay, so this is what you're gonna do. It says draw a triangle with side length of 2 centimeters, 4 centimeters, and 5 centimeters. So this is what I'm gonna do. I'm gonna create my 3 segments. This is how you do it. Okay, so 2 centimeters, it's gonna be right here. Okay, 2 centimeters. So I put the end point right here. Then 4 centimeters. Okay, let me see if I can start from 0. I mean, it really doesn't make a difference, but still. Okay, 4 centimeters. That would be from 0 all the way to 4. So this was 2 centimeters, this is 4 centimeters, okay? And now 5 centimeters, okay? From 0 to 5. So these are your 3 segments, okay? So now what I'm gonna do is I'm gonna draw my first segment. Now, you really don't need the ruler. You could just use the compass, but still. So, I'm going to draw it around here. So, 5 centimeters is going to be from here to here. Oh my God, I really need to sharpen my pencil. Okay, now I got it. All right, now I'm gonna be able to do it better. All right, so 5 centimeters. So from that, guys, what you're gonna do is you're gonna take the little compass, okay? And let me zoom out a little bit, okay? You can still see it. You're gonna open the compass, adjusting the adjustable wheel to the length of 5 centimeters. So I'm gonna put a tip of a compass right here, and the other one, almost right here. Okay, and what you're gonna do is you're gonna swing an arc like this. Never mind if it crosses the segments that you already drew. So you do that. Okay, next you're gonna go to the other longest segment. So you're gonna put the compass here, and you're gonna adjust the wheel so it hits the other one. See that? And you're gonna repeat the same first step. You're gonna put it here, and you're gonna draw an arc. Okay? Now with that arc drawn, then proceed to the next step. The last step is a little different. So you put the compass on the segment that measures 2 centimeters. You adjust it to the other end point, like here. Okay? See it? Let me zoom in now. Okay, that's it. You put it right here, and now with that length you're gonna go to the other side of the segment here. Okay, here, not here, here, and you're gonna draw another arc. You could do it like that if you want to. Now, what am I concerned about? I'm concerned about this intersection point of the 2 smallest sides. And now all you gotta do is connect the sides. And this is how you draw a triangle with a given length. All right then. Now, you saw my triangle. I want you to try using the same technique. I want you to try. Why is it blurry? Now I want you to try drawing a triangle with side length of 2 centimeters, 3 centimeters, and 6 centimeters. All right? Take 2 minutes. Do it. And reach a conclusion. As soon as you reach a conclusion, boom, raise your hand, call me, tell me what your conclusion is, and I'll give you 1 point. So this is going to be my 2 centimeters right here. Okay. This is going to be my 3 centimeters. And this is going to be my 6 centimeters. Okay, so this is 2, this is 3, and this is 6. Now, with that, you could just go on to the other side, okay? And you draw your 6 centimeters. I'm going to do it over here. 6 centimeters is from here to here. Then remember what you gotta do. You go onto the other side. Okay. You adjust the compass to the length of that side. And from here, you swing an arc. Then you go on to the other one right here. You adjust the compass. And this time you're gonna do it from this side. Okay? Now, take 30 seconds to reach your conclusion. Alright, if you got it, you got it. So I'm gonna draw the arc. Alright, I got a problem. The two arcs don't intersect. But hold on a second, they don't intersect? No. So, what are you talking about? Well, look at the first problem. Actually, the first problem, you didn't even need the first arc, the longest arc. You only needed the two smallest arcs. But look at this, the arcs intersected, so I was able to form a triangle. Here, the arcs don't intersect, so I cannot form a triangle. Okay, so right here on this page, I'm going to explain to you what's going on. It is said that two sides of a triangle, when you add the two sides, the length of the two sides of a triangle, that length must be greater than a third side. Any two sides, any sum of the two sides must be greater than the third side. So let us look at the second problem right here. And let's see if it's true. 2 plus 4 is 6. Is that greater than 5? Yes. Okay. 5 plus 4, is that greater than 2? Yes. What was the other one? 2 plus 5 is 7. Is that greater than 4? Yes. So that's why this was able to be a triangle. Now here, if you look at it closer, why is it that we were not able to draw a triangle? Easy. 6 plus 3 is greater than 9. 6 plus 2 is greater than 3. But 3 plus 2 is 5. 3 plus 2 is 5. That's not greater than 6. Therefore, a triangle cannot be formed. Nice, right? That was quick and easy. I told you. All right, then. So now here you have your explanation right here. Okay, what did you notice? We did. So what they did is that they put side B right here and then side C. And they expanded. And it was greater than the length of side A. Then they did the same thing for side B, and side A was greater than the length of side C. Then they did the same thing for side C and side A. See, when you put both lengths together, it was greater than the length of side B. So that's why, okay, that's why this is able to become a triangle. All right then. So now, let's go on to the little problem. So it says 3 segments have lengths of A equal 3, B equals 6, and C equal 4. So question is, can a triangle be formed by these measures? Well, let's see. 3, 6, and 9, right? So, 3, 6, and 4. Is 3 plus 6 greater than 4? Yes. Is 3 plus 4 greater than 6? Yes. Is 6 plus 4 greater than 3? Yes. So a triangle could be formed. Now example number 2. You got the three lengths. You got 7, 16, and 8. Okay? 7, 16, and 8. So let's start working with this. Let me zoom out a little bit. Okay. So 7 plus 16, is that greater than 8? Yes. Okay. 7 plus 8, is that greater than 16? Yes. Question. 16 plus 8. Wait, hold on a second. What did I miss? Where did I miss? Oh my God. Sorry. Let's go back here. 7 plus 8 is 15. Is 15 greater than 16? No. Oh, so guess what? This condition is not met because of these two sides. The sum of these two sides is smaller than the third side. So a triangle cannot be formed. All right. Let's check your understanding and let's see what's going on. So, it says, in the diagram below, okay, this is a triangle. D is a point on AB, okay? And they give us the length of each side. They don't give us this. Question is, the length of DB could be. So they want this length. I'm going to call this length X, or I could call it a box, or I could call it N, I could call it whatever. I need to know what this length is. All right? So you got choices. If the length of this X was 5, then the length of AB would be 11. So let's try that. 11 plus 7 is 18. This, is it greater than 18? No. So this cannot be the length of DB. Let's try 12. If this is 12, then 12 plus 6 is 18. So AB is 18. So 18 plus 7 greater than 18? Yes. 7 plus 18 greater than 18? Yes. 18 plus 18 greater than 7? Yes. So a triangle can be formed right here. Now guess what? Some of you might be saying, yeah, but what about 19 and what about 25? Sure, let's use 19. If X is 19, 19 plus 6 is 25. Hi.
Hi.
How you doing? You good? All right. What do you want? Play-Doh? Okay. We go later. Jesus Christ. Okay. So 19 I said, right? 19 plus 6 is 25. But guess what? 7 plus 18 is 25. So this sum, okay, 25 plus 7 is greater than 18. Okay. But 18 plus 7 is 25, and that is not greater than 25. Suppose, okay, pretending that this is 12. So then, this cannot be a triangle. The same thing goes for 25. Use your common sense. Alright. Let us move on. Which of these numbers represents the length of the sides of a triangle? Well, let's see. 5 plus 18 greater than 13? Yes. 5 plus 13 is 18. That's not greater than 18. So therefore, this is not a triangle. So this is not the answer. And then 6 plus 22, okay, you get the hang of it. Okay, so take 1 minute or 30 seconds to figure out what the answer is, okay? All right, so we got our answer. Our answer is 4. If you raise your hand and you call me, then I'll give you a point if you gave me the right answer. Once again, in triangle ABC, AB is 5, this is 3. Which inequality represents all possible values for AC in feet? All right, so first of all, I cannot work like this. I'm gonna have to use a visual, so I'm gonna create a triangle. I don't even need the ruler. I'm just gonna do a triangle like this. Okay, so one of the sides, okay, in triangle ABC, so let me call this A, B, C. Okay, so AB is 5, so AB, side AB is 5. Okay, BC is 3. Okay, so now, possible values for AC. Sure. What do I know? That 5 plus 3 must be greater than this, so 5 plus 3 is 8. Okay, so what are the possible values here? Okay, it could be 7. It could be 6. It could be 5. Can it be 4? Well, let's see. 4 plus this is 7 than this, yes. This plus 4 is greater than this, yes. So it could be 4, okay. Can it be 3? 3 plus 3 is 6, greater than this. 3 plus this is 8, greater than this, yes. Okay, so now can it be 2? 2 plus 3 is 5. Nope, it cannot be 2. Why? Because if I put 2 over here, 2 plus 3 is 5. That's not greater than 5. So forget it. All right then. So the range is from 7, okay, till 3. So does this work? Yes. But is this the answer? No. And why? Because we couldn't include the 2 over here. And if you read this, it says AC is a number between 2 and 8, including 2 because of the or equal to sign, and including 8 because of this or equal to. Okay. AC is between 3 and 7. Including 3, okay, we have that. Including 7, okay. So this could be one of the answers. But then again, we have a problem. And I'm going to tell you, well, it's not really a problem. This is one of our answers, okay, because I got the number 7 and 3. Now look at this choice. This choice, my friends, is the same as this one right here. This one says AC is a number between 2 and 8, not including 2 and not including 8. Wait, if you don't include 2, the next number is 3. If you don't include 8, then the previous number is 7. Oh gosh, so this could also be an answer. Okay, if you find a discrepancy and you think that cannot be an answer, then you tell me, okay? Now this definitely cannot be an answer because it says that the number is between 3 and 7, not including 3 and not including 7. And we already know that 3 and 7 must be included. Alright, good, so we got 2 choices right there. Now, is it always the case? No, this is a one of a kind question, okay, where you have 2 choices. Usually, most of the time, 99% of the time, you're only going to have 1 choice. All right then, so guess what? Let's see, in PQR, okay, I need to draw a triangle. Since they're not specifying that this should be a right triangle, then I don't have to draw a right triangle. So PQR, P, Q, R. Oh, okay. PQ is 8. QR is 12. RP is 13. What do they want? Which statement which statement about the angles must be true? Angles of this triangle must be true. Okay, notice that these are greater than symbols. That means that the measure of Q must be larger, okay, greater than the measure of P. And the measure of P must be greater than the measure of R. What does that mean? Easy. That we have to arrange the angles from largest to smallest. That's all it says. Okay then, but how am I going to do that? Oh, you forgot. Don't worry, I will tell you right now. Opposite to the longest side is the largest angle. So the largest angle here is P. Remember, opposite to the smallest side is the smallest, opposite to the shortest side is the smallest angle. So the smallest angle is R. Oh, okay, I get it. So R. So what does that mean? That the middle angle must be, wait, hold on a second. How did I get this? Okay, let's go back here. I made a mistake. I thought that 12 was the longest side. If you corrected me before I corrected myself, I'm going to give you 2 points. The longest side is not 12. The longest side is PR, which is 13. So opposite to 13 is angle Q. Oh, okay. So guess what? The largest angle is angle Q. The smallest, of course, is still angle R, and the mid-size angle is angle P, because that's 12. Opposite to 12 is P, so angle P. So I just put them in order from largest to smallest. QPR. So QPR. So guess what? Choice 1 is your answer. Okay? Let's do this one. It says in triangle, okay, once again I got a triangle. Okay? ABC, A, B, C. So AB is 7. BC is 8. Notice how I label sides. If they were talking about angles, I would go inside the triangle. Alright, and AC is 9. Alright, cool. So which statement, okay, which list has the angles in order from smallest to largest? Smallest to largest, sure. What is the smallest angle? Well, this is the shortest side, so the smallest angle is C. The next smallest angle is, in order, is what? Well, the next shortest side is BC, which is 8. So opposite to 8 is angle A. And of course, the largest, well, the longest side is AC, so opposite to AC is B. So now we'll look at the choices. CAB, which one has CAB? CAB right here. Boom. And that's your answer. Okay, let us move on. Let's see what we got here. Alright, in triangle ABC, once again, visual. Okay, A, B, C. Now angle A is 95. Okay, angle B is 50. See how I'm putting the numbers inside. Now if you cannot put it inside, then you make a reference arrow pointing that is an angle. So angle C is, wait, oh my god, I made a mistake again. Angle B is 50 and angle C is 35. Okay, now once again, if you catch me in one of my mistakes, I'll give you 2 points. Alright then. So now, what do they want? Which expression correctly relates the length of the sides, okay, of the sides of this triangle? Justify your response. And then they give us some choices right here. Now notice that the symbols here, the inequality symbols, are less than, meaning that this is smaller than this one and this is smaller than this one. Oh, so that I'm going from smallest to largest. Okay, and we're talking about sides. So let's see, which one is the smallest side? Well, the converse is also true. If opposite to the longest side is the largest angle, then opposite to the largest angle is also the longest side, and vice versa. Okay then, so let's go from smallest to largest. Which one is the smallest side right now? Before I write it, 1 point, 5 seconds. AB, very good. What is the next smallest? Well, right here I have an angle of 50, so the next smallest is AC. And then the largest would be BC. So we got AB, AC, and BC. Which one is the answer? Ooh, Lil Wayne. As long as my girls love me, my girls love me, my girl loves me. Oh, with no makeup, she's a 10. She's the best with the brains. Okay, so let us move on to this one. Alright, that's it. You can actually do this on your own, but just remember, it's always easier if you have a reference, a visual. How do I get this? Well, you tell me. Let's move on to our next problem. You know what? You could do this on your own. I'm not going to tell you anymore. You already know what to do. I have a visual, so take 2 minutes to answer this question. So RS is smaller than ST, and ST is smaller than RT, so you make your selection. Now, this one says RS, this one says TS, so TS and ST should be the same thing. Oh, okay, Becca, I'm sorry. Just never doubt me, son. Never doubt me. If you doubt me, you get this. In the diagram below of triangle ABC, at least they gave me the diagram. Okay. What do they want? Which side of ABC is the longest side? Wow. Which side is the longest side? Therefore, I have to utilize the external angle theorem of triangles. So, this external angle is 117. You know what? No. I'm going to offer you 5 points right now. Take 2 minutes to do this. How do I know this? Well, because of the triangle inequality theorem, which states that what does it state? Wait, hold on a second. Oh yeah, I know how to justify this. Okay, so how do you know this? Easy. Because first I use the triangle inequality theorem, which says that the what triangle inequality? No, I'm sorry. I used the what? What do you? Oh, external angles of a external angles of a triangle. Damn, I've been recording so much that I'm losing myself. Okay, so the external angle theorem says that the sum of an external angle is equal, the measure of an external angle is equal to the sum of the two non-adjacent angles. So that's how I figure out the measure of all angles in a triangle. Then, okay, I used the theorem that says that opposite to the largest angle is the longest side. Oh, so that's how you knew that AC was the longest side. Yes. And that's how I justify my answer. And you know what? Let me rephrase it again. First, I used the external angle theorem of triangles, which says that an exterior angle in a triangle is equal to the sum of the two non-adjacent angles. And then I remember that there's a theorem that says that an angle opposite to the longest side is the largest, and a side opposite to the largest angle is the longest. Oh, I got it. Okay. Damn, I just spaghetti myself. I tangle myself into this. All right, so what does it say here? Define using your own words what is the triangle inequality. What the triangle inequality theorem states? It states that the sum of any two sides of a triangle is greater than the length of the third side. I don't have to write it down. You already have it in the mini lesson. So just refer back to the mini lesson so you could write down your summary. All right? Good. All right. Quiz number 25. Wow, we've been through this already. Here they want the length of the base. This is an altitude. So this is x and this is x. All right? All right, so now I'm going to use Pythagoras because this is a right triangle. So I'm going to say, okay, the length of the hypotenuse squared is equal, okay, to a squared plus b squared. Okay, so a squared is going to be x plus 7 squared plus the other leg, so that's x squared. All right, so 169 equals, and then what is x plus 7 squared? You are squaring a binomial. Okay, that means you're multiplying this by itself. So how do you do that? Easy. Square the x, get these two together, 7x, right? 7x times 2, that's 14x, and then plus x squared. Then you're gonna combine like terms, so you're gonna have 169 equals x squared plus x squared is 2 of this, so 2x squared plus 14x. Then we know that this is a quadratic equation because I did not cancel anything. What's up? Huh? What's up? Nothing. Okay, so now we're gonna equal one of the sides to 0 because this is a quadratic equation and quadratic equations should be equal to 0. Okay, so subtract 169 from both sides. Wait, I missed something here. What did I miss? Oh gosh. Hopefully you caught it and you corrected me. I forgot to square the 7. So this is 49 and then plus x squared. 49, okay, plus x squared. Oh no, I did already added the x squares. Okay, so here I have 2x squared plus 14x plus 49 minus 169, because remember that I subtracted it. Okay, so what do I get? 0 equals to 2x squared plus 14x, and then 49 minus 169 is negative 120. Okay, then we proceed to factor. So greatest common factor is 2, and then the remaining is x squared plus 7x minus 60. Then we continue with the factoring, so we open the parentheses and we say factors of x squared is x and x. Factors of 60, well, we already know it was 12 and 5 because 12 times 5 is 60. I do the smiley face, so I get 5x and 12x. How do I get 7x? Make this positive, make this negative. Okay, are we done? No. So now we have the solutions. What number plus 12 is 0? X equal negative 12. What number minus 5 is 0? X equal positive 5. So we're going to use the positive value of this and we're going to substitute it into our base. So this is 5 and this is 5. So the total value of the base is 10. So please write it down. Write it. Like the value, okay, the length of the base is 10, whatever units they're giving you. Okay? Oh God. I'm tired. Alright. Now this problem right here. Okay, so it says a kite needs a vertical and a horizontal support bar. This is the vertical bar, this is the horizontal bar, okay, attached to opposite corners. The upper edges of the kite are 7 inches, the side edges are X inches, and the vertical support bar is X plus 1 inches. They want what? They want what is the measure in inches of the vertical support bar. They want to know what this is. Okay, so look, two right triangles. So I just need to use one of them. Leg, hypotenuse. Opposite to the right angle is the hypotenuse, so that's what I'm gonna do. So I'm gonna start using Pythagoras. So tell me what is the hypotenuse? The hypotenuse is X plus 1. So X plus 1 squared equals to A squared plus B squared. So 7 squared plus, and then X squared. Okay. What is X plus 1 squared? You already know how to square binomials. So square this one, so I get X squared plus, put this together and times it by 2, so you get 2x plus 1 equaling to 49 plus X squared. Alright, if we examine this, we have the same terms on both sides. That means that they're going to cancel out. How? Well, sometimes you end up with quadratic terms, but doesn't mean that you're gonna wind up with a quadratic equation. Because look, I'm gonna subtract x squared here. It cancels out. What I do to one side, I do to the other. Guess what? They're gonna cancel out, and that just leaves me with 2x plus 1 equaling 49. See what I'm saying? And now subtract 1 from both sides, and then divide by 2. So x is 24. But you already know that that's the value of x. They want the value of the vertical bar. So the value of the vertical bar is x plus 1. So vertical bar, okay, vertical bar equals, okay, x plus 1 will be 24 plus 1, which is 25. As simple as that. Alright then, so that was it for your quiz. On the other side I left some graph paper. I have no idea why. Now on the next lesson we're going to be looking at the side splitter theorem. Alright, bye.